Hi, welcome to Introduction to Binders through SciConnect Initiative. This course is going to be split into two parts. The first unit is going to be how to create your binder, aka the information in it, and then the second part is actually physically putting your binder together. So let's start on Unit 1, which is the binder contents. So first of all, I would like to preface this by saying that binders are for you. And this course is mainly for those who have not made a binder before, and if you're unsure where to start, don't take it as like what you're supposed to make a binder to be. For example, if you're really good at memorizing, you might not need a big binder. Maybe you just need 10 pages with some equations. If you're someone that prefers not to memorize like me, you can include more information in your binder that covers everything in your event to refer to. Your binder, it can be all images that you like, it can be just a bunch of text if that works for you, it can be like a single picture of a cat. You can also walk into a binder event without a binder and still win. Some of my friends have done that before, so it definitely happens. The binder is what you want it to be. But again, if you're not sure how to start a binder, let's get going. So first I'd like to talk about non-ID binders. Inside of the specs for each event, there's usually a bunch of bullet points about the topics that it's going to cover. And this is a perfect place to start on your binder. Usually I like to divide my binder into these sections anyways because that's how some tests are organized and it makes it a lot easier. Now, based on all this information, this is obviously just like base level bullet points. There's a lot of different ways where you guys can fill this information out. One option that you can do is have a big Google Doc information of info. So you can see here, this is like a 100-page document for my personal optics binder. So we have it in the order of like the bullet points and the specs of all the information, and then I break each topic into different subtopics of things that I should focus on. So for example, one of the topics in optics is reflection. So I have another subtopic here of total internal reflection, which takes up a whole page. Inside of your Google Doc, you can basically do anything you want. You can take your own notes and have bullet points on that. You can copy and paste information from websites. You can add any images, diagrams, etc. that you want. For example, on this page, I'm pretty sure these paragraphs are copy and pasted from some website online, and these bullet points are things that I wrote myself to remind me. And then I also included images so that I understand the material better. So obviously, in this Google Doc, you can put anything you need that is helpful. In addition, something really good to put inside of your binders is worked out examples, especially if your event has a lot of physics calculations or just calculations in general. Because this way, if you're freaking out in a test and you're like, oh my gosh, I have this equation, but I don't know what to do with it, you can refer back to these examples and understand how to do these problems. A binder is a lot of information that you can fit in, so put whatever for you is personally helpful. For me, I like these worked examples, I like having summaries of the information, and I like having diagrams. So again, a binder, it's really, really important to have a lot of images and diagrams, and I would say especially for the earth science events. So one of our earth science friends who does binders made this page, and some things to put is common diagrams that might appear with tests. For example, the water cycle, and you can have a bunch of different versions of the water cycle to really remind you what's going on. And this will also help to save a lot of time when filling out the blanks. Because, for example, let's say you get a test and you have the water cycle, but all of the parts are blacked out, and it has you fill out what each section is. You can just refer back to your diagrams and fill this out. For wind power, a lot of times they give you a blank diagram of a wind turbine, and if you have a diagram of a wind turbine in your binder, you know exactly what part goes where. So a lot of images and diagrams are definitely very helpful. And don't feel limited to just one image per topic. You can do as much as you'd like. Something else to include is a glossary, which includes all of the necessary vocabulary related to the specs. You can take this from multiple sources, whether it be Google, government agencies, research institutions, etc. Having this just list of vocab elements with their definitions, first of all, a lot of tests have pages where you fill out definitions of vocab. So you can basically just refer to this and understand exactly what you need to do. On top of that, having this glossary for any event, if you forget what a term is, if you need to refer back to a concept, you can just go to your glossary, look in alphabetical order, and find exactly the term and the ideas that you need. So having this glossary is very helpful. In addition, if you are using Google Docs, you can use the headers and the subheaders that are built into Google Docs to create a table of contents for yourself. You go to insert table of contents, you guys can Google how to do that, and Google Docs automatically generates a table of contents for you with page numbers. So if in your Google Doc you have turned on page numbers, you have the headers and subheaders, then this page is so helpful. This is probably my most referred to page in my own optics binder. This is screenshotted out of my binder, and I know exactly what page to go and look for each specific concept. So now I'd like to talk about printing things for your binder. You can print anything. You're not limited to things that you write yourself. A lot of things that people print in their Stylo binders is from Wikipedia, from websites, or from textbooks. So I'm going to show you guys really quick how to print from Wikipedia and websites effectively. So let's talk a little bit about printing. So I think printing for a binder is such a helpful skill to have because a lot of times if you just try to print websites, it doesn't work out well. So let's take a look at this. Why is grapefruit good for you? I've been really into grapefruit lately. Let's say this is information you really want to include in your binder. And let's say we try printing it. And you know, it's okay, but it's like a little bit weird. Like the formatting is a little bit off. There's like random things that you don't necessarily want. The way that all of the headings and then like the images and like things are split weirdly, right? So here's some better ways to print things. First of all, let's talk about Wikipedia pages. Wikipedia pages are so good to print in Science Olympiad, and this is usually how you want to do it. So if you just click print, it already looks pretty good because of the way that Wikipedia is. But something that you should definitely do is put it onto 4 pages per sheet. So this is going to make it so that the text is still readable. Honestly, it's like maybe a 7 size font, but it takes up so many less pages than if you were to print the whole thing. So let's go back to 1 page per sheet. This is 6 sheets of paper if you're already double-sided. And if you do 4 pages per sheet, it's going to be 2 sheets of paper. And along with this, we don't need every single page here. We don't need any of these references for sure. So what we're going to do is we're going to go to pages here, custom, and I'm just going to see, we have 1, 2, 3, 4, 5, 6, 7 pages of content. So 1 to 7. And this is so nice and clean. And now you have everything you need about grapefruits on literally 1 sheet of paper instead of 6 sheets of paper or 12 sheets if you do it single-sided. It's so helpful. In addition, if you're printing PDFs of textbooks, which I hope you got legally, then I would also do the 4 pages per sheet method, or else it's just way too much paper to have in your binder. If you're printing websites, you can use another method. Something that I like to use is print friendly. So that is this Chrome extension right here. You can search up print friendly Chrome extension. If you click this, it prints beautifully. Like you see this table, like it's so perfectly formatted. Everything is so beautiful and perfectly formatted. In addition to this, you can get rid of things that you don't want. So let's say we don't want this related coverage section. Hover over it, delete, delete, delete. There. And now you have all the information that you want. You can also make the text size and the image size smaller. So let's say I don't really need that big of a picture of a grapefruit. Let's make it smaller. We can make the text size a little bigger if we want to. And then from here, you can go ahead and print it. And it looks absolutely beautiful. And now I'm going to bring it on to Joelle, who is going to talk a little bit about ID binders.
Hi everyone, my name is Joelle. Just some context on who I am. I've competed in almost every single ID binder event for the last 4 years in Science Olympiad, including ornithology, fossils, rocks and minerals, forestry, and now entomology. So I'm going to be giving you some advice on how you can best optimize your binder for specifically an ID binder event, which I define as an event that gives you a long list of specimens that you need to be able to identify from pictures. And for the 2025 event rotation, those events are going to be entomology and fossils. So for an ID binder test, there's going to be kind of 3 different types of questions that you're going to want to optimize your binder toward. So the first type of question is obviously going to be ID. The rules state that you're going to need to be able to identify all of the specimens from the list, this year being insects for entomology or fossils for fossils. And in order to prepare your binder for these ID questions, it can be really helpful to have what I call an ID page, which is basically just a document where you put images of every single specimen on the list. So you want to be studying ID on your own time, whether it's using a flashcard set or using the Discord identification bot. But sometimes you just forget what a specimen may look like, or maybe your field guide doesn't have too many pictures. So that's why it's good to always have a lot of images in your binder. And a good way of doing that is to just put images for every single specimen into a document. The next type of question is going to be questions about each of the specimens on the list and asking about characteristics. So for example, for fossils, this could be something like the stratigraphic range, the time period that the fossil existed, or maybe the anatomy questions or morphology questions or questions about its behavior or ecology, and that can also all pertain to insects for entomology. So you're also going to want to have a specific page to every single specimen on the list that gives you a lot of information, and preferably like with a lot of detail, so more detail than a field guide would give you. And also because it's almost impossible to memorize all of that information for the 100 to 200 specimens that might be on the list, that's where your binder steps in, where you can print out a lot of information that covers every single aspect that the rules say you need to know for every single one of the specimens. So you want to do this for the 100 to 200 specimens on your list if you want to have all the information covered. And the last third type of question that generally shows up on tests is just general trivia questions or science concepts. So for entomology, this might be something like pest control, integrated pest management, or knowing about insect anatomy in general, or knowing about arthropods, or knowing about exoskeletons, knowing about, or for fossils it might be knowing about evolution, or knowing about the geologic timescale, or knowing about absolute and relative dating techniques. So these are all more general science questions that don't necessarily apply to a specific one specific specimen. So you're going to want to also have some articles printed out in your binder that will cover all of that general science. Also here, I forgot to cover this under the identification section. I mentioned reverse ID pages. So what I mean by that is you have a document where you can categorize similar characteristics, or categorize specimens that share similar characteristics. So that it's just easier to reference. So for example, you might get a question that's saying, oh, this insect has sucking mandibles, so what possible insects would it be? It's not very efficient to have to flip through every single page and find, oh, this one has sucking mandibles, this one has sucking mandibles. So you could create a document where it has the different categories of mandibles, and then you list every single specimen that has that characteristic. So these kind of reverse ID pages, it allows you to identify what a specimen is from its characteristics. An example of this for fossils might be a question that asks you to order a list of fossils in order of when it first appeared in geologic time. So then you could create a reordered list in order of when it appeared in geologic history, and that could also be a really useful thing to have in your binder. So those are just examples of creative ways of how you can make documents in your binder to prepare you more for answering questions. And the best way that you can think of what to add to your binder is just by taking a lot of practice tests and thinking about what would be useful to have in your binder for an actual test. So getting into the specifics of how you can make some of these pages, I have some examples from previous events. I have ornithology and rocks and minerals examples. There's a few different ways you can make ID pages. The most common way is what I also recommend when you're just starting out is on the left. You can see that for every single bird. We have a picture of the male, the female, juvenile, and also the eggs and the nest. So you can see that there's a variety of pictures that covers different variations of the specimen and also the nest, but it doesn't have too many pictures. It's only 5 pictures. So pros, it's more space efficient. Cons, you don't have that many photos here compared to this page, which is the rocks and minerals page that I used when I was competing at nationals. I pretty much just screenshotted Google Images and put it into the paper. The con of this is that it is super long. It uses a lot of space. This document might have ended up being like 20 to 30 pages long. But the pro is that you basically have Google Images inside of your binder. So this is really useful for having a lot of obscure pictures when ID can get a little harder at a more advanced level and you just have no clue what it is. You can literally match the picture to what is a search result in Google Images. So these are just two different options that you can use. This one uses a lot of space, but you have more images. This is more practical, I would say. And then another thing you might want to consider when making ID pages is making some specialized ID pages for more specific characteristics. For example, for ornithology, we had an ID page that was just skulls. So in case a question ever showed us a picture of a skull and asked us to identify the bird, we would be able to use this guide to help us out. This could be definitely a consideration for fossils. You can make a guide just for dinosaur teeth, or teeth in general, I guess, because that can be a pretty difficult thing to identify. Or maybe for entomology, you want to just have a guide of wing venation, or maybe the distribution of insects. Those are all options that maybe if you feel that that's a more hard question, you can make a specialized ID guide just for that type of characteristic. The next thing you definitely want to have, as was mentioned in the previous video, you really want to have a lot of diagrams. This is pretty straightforward. Just think of any possible questions that could be asked on a test and find as many diagrams relating as possible. So this was one that I had for forestry. I mean, it ended up being like almost 10 to 20 pages of diagrams. This is only one page, and this was from rocks and minerals. So these are just some examples. I think it could definitely be more space efficient than this. You can see that these examples, there's a lot of empty space. So you do kind of want to think about being efficient, especially for an event like entomology, which this year does have a 2-inch binder limit. While fossils, you do have infinite space to use for your binder. Next is glossaries. This was also covered in a previous video. There's a few different ways you can do this. Wikipedia has a lot of really interesting glossaries that already exist as articles. This is especially true for entomology. I believe there's like a glossary of ant vocabulary or something like that. So that can be something interesting to have in your binder. You can either copy and paste that onto a document if you want to make it more condensed and space efficient, or just directly print it from Wikipedia. It's just up to preference. If you can also try Googling just entomology glossaries or paleontology glossaries, there might already exist a vocab list that someone made online or some organization might have made online, and you can print that out. So this is an example. I think this might be the Audubon's bird glossary. I'm not 100% sure, but this is the one I had for ornithology. You can see they had a lot of terms that ended up being like 20 or 30 pages long, but it was very, very useful. You want to make sure that you're taking advantage of columns in Google Docs to save space, and you're going to be able to fit a lot more. And then also have an organizational method, probably alphabetical is going to be the best. And you know, it's also okay if you have some extra space. And the reason why is that if you're taking practice tests and you notice, hey, there's a vocab word I didn't know and isn't in my guide, you can just write it in and you don't have to reprint your vocab guide every time you learn a new word. So having empty space might be an advantageous thing to do. So next is having those list-specific pages. So here are just some examples from rocks and minerals and ornithology. I would say there's kind of 3 different strategies you can use. You can make your own kind of Google Docs template. I always like to have the sidebar that Wikipedia includes, which is like a quick access type of bar that has a lot of the facts and general information that is asked a lot on tests that applies for entomology, especially. I think Wikipedia includes this little box here of important information. So I always like to include that in my Google Docs, and I just create my own headings. And the benefit of making your own document is that you can customize the order of information that's included. You can make sure that maybe if Wikipedia doesn't have some information, you'll be able to add in information from other articles and other sources. And you can just customize your fonts and spacing in a way that suits you the best. So I know some people, they prefer using handwriting fonts, so fonts that look like they're handwritten because it's easier on the eyes to read. And then some people like to have like no spacing, like 0.5 line spacing spacing. Some people would like to have more spacing. So using a Google Doc just allows for more customization. And then you can also, for general information, just copy and paste Wikipedia articles into a document. Just maybe if you're really particular about formatting, you want it to look a certain way. And then Wikipedia is just, if you don't have a lot of time, just print out a Wikipedia article. It'll probably be sufficient for information. You're going to be missing some info, but it'll really get you the basics. So yeah, that's 3 different strategies that you could use for making these kind of bio pages for all of the list specimens. And finally, organizing your binder. There's going to be another video that goes more in depth on how to tab, but this is just an example of how I organize my ornithology binder. Before all of my list-specific pages, I included some general information pages, and then I tabbed every single family. I don't think I tabbed every single bird because that would be a lot of tabs and it's difficult to read sometimes, but that is all up to personal preference. And I personally like to make tabs from copy paper, and then I kind of laminate the tab with a piece of tape, so then it's more secure, and I tape it into the binder myself. I don't use just normal sticky tabs like a Post-it because I find that they fall off a lot. So if you do that, you might want to also use some tape on top of that, or else it'll fall out with continuous use. I also really like to use some of these binder organizers for maybe some broader categories, so you can combine these methods and just find what works best for you. So this was some information about how you can try and organize and prepare your binder for ID binder events, and I hope that was helpful.
Hi everyone, welcome back to Introduction to Binders. We are now on Unit 2, which is putting together the binder, which is also the last unit. So first of all, let's talk about the type of binder. Honestly, the main thing is just to make sure that it fits in the specs. Some events, for example ID events, have binder limits, like you can only have a 2-inch binder, so make sure that you're not buying anything bigger than that or else you might not be able to use it. In addition, it doesn't really matter that much, but I personally enjoy a D-ring binder. I feel like it's able to fit a lot more information through to the straight edge, and also just like holds up sturdy as a binder. You can also get binders of fun colors. For example, this is my sister's wind power binder. It's light pink. It's pretty beautiful. You can also like decorate the covers of your binder and stuff and make it fun and make it yours. I would also like to say, even if your binder allows for unlimited size, for example, physics binders, you really don't need to have that big of a binder. Like, you don't need a 5-inch binder just because you're allowed to. For example, this is my own optics binder that I've won a lot of awards with. It's just a 1-inch binder. It has all the information I feel like I need in it, so I don't go bigger. So now let's just talk really quick. I think the first page of your binder should just be a printed out version of the specs for your event. It's a good reference no matter what, and if you're in a physics event where there's a build section or a lab section, it's really helpful to refer back to. Okay, now let's talk about sheet protectors. This might feel a little bit random, but it's something that can come up a lot. First of all, let's talk about the advantages and disadvantages of using sheet protectors. Some advantages are that the pages will flip faster because they're like a lot smoother, so you can go through it really fast, and you don't have to worry about it breaking because paper is obviously, it could just rip. Also, if you use a sheet protector, there's no need to hole punch any of your pages, which means that on this edge right here you can see, you can go as close as you want without having to worry about the margins. If you have a non-sheet protected binder, that means you have to leave at least like a 0.5-inch margin on the side to account for hole punching. I think that this is more important in ID events because usually you have like an animal per page, so you want to maximize each page. But yeah, some disadvantages of using sheet protectors is that it makes the binder more bulky because obviously it takes up more room, and it's like you have to use a lot of time to put every single sheet of paper into protectors. So on the topic of sheet protectors, it's really just about how you want your binder to be. You have a few options here. First, like this binder you're seeing over here, this is a wind power binder. You can sheet protect every single page, which is going to make your binder really, really safe. It's pretty beautiful and smooth, but it is like a pretty fat binder. Something else you can do, and this is what I personally do, you can sheet protect important pages, for example, specs, conversions, and other reference materials. For example, if we look at my optics binder here, I have like my conversions and stuff in a sheet protector, and then after that it's just like all regular hole punched papers. I honestly was too lazy to do sheet protectors, so that's why I did that. And your third option is just don't sheet protect anything, hole punch all of your pages. What you do with sheet protectors is honestly up to you, but it can be something very helpful if you're someone that likes to flip through binder pages really quickly. Next, I think something really, really important to discuss is tabs. Oh my gosh, tabs are literally your savior when making a binder, and I'm not exaggerating at all. I think that when you're making a binder, outside of the content, tabs are one of the most helpful things during a test. And this is because you don't have to be flipping through all the pages or like keep looking back at a table of contents and then trying to find the page number. You just have tabs of everything important. There are a lot of ways that you can make tabs in a binder. You can have tabs all over the sides, all over the top, etc. You can tab as little or as much as you need. Maybe you only need 2 tabs of important things. Maybe you're like me and you like having a million tabs. For tabs, there are a few different things you can do. First of all, you can use mini sticky notes. So like, for example, here's some mini sticky notes and you can put them on the sides. You can also cut up the mini sticky notes to make like thinner tabs. That's actually what I have over here. It's these mini sticky notes cut into fourths. So the sticky part goes onto the page and then I write the description on the side. You could also use like actual post-it tabs here. You can use these sticky tabs. You can use a piece of just regular white paper, cut it into strips, and then tape it in. You can basically do anything. You can also find like cute tabs. Like I have a donut over here that makes me really happy. These things you can find at Daiso, at Target, on Amazon, anywhere. Something else that you could do is those like dividers in a binder that have tabs that you can write on, as well as like pockets. You usually can't have anything in the pockets, but these are good if you want to separate big sections of your binder. Ultimately, how you tab your binder is up to you, but you definitely should tab your binder. So a few options of how to tab it. Over here, the way my WinPower binder is organized is I have these big red tabs for the main categories of information. And then I have these small yellow tabs of things that I feel like I refer to more and I want to find. So for example, you can see like if I want to learn about WinPower blades, I have a tab right here. If I want to do calculations, I have a tab right over here. Some other ways is over here in my optics binder, I have main ideas in all the red tabs along the right. And then I have, again, this is our calculation things that I refer to a lot over the top. This is my sister's WinPower binder, and she has these really, really pretty pastel tabs going all the way down of a bunch of different topics. So yeah, I hope you guys enjoyed this course about Introduction to Binders. I've been armed with some of my binders throughout this course, and I hope that you guys learned a lot from this and are able to create your own efficient binders. Thank you.